consider the production function. Q is given by this expression. We have a couple of questions to answer. The first one, derive an expression for the optimal amount of capital K and labor. The second one, derive the total cost function, average cost function, and marginal cost function. And the last one, sketch the total, average, and marginal cost curves. So let's begin by working with the first one. We need to find the optimal amount of capital and labor. How do we do this? So the first thing that we need to do is to set up the Lagrangian multiplier, which is just like so. The objective plus lambda multiplied by the constraint, like that. But what is our objective function in this problem? And what is our constraint? So to analyze that, we need to remember that firms always aim to maximize profit, which is just the total revenue minus the total cost. So to maximize profit, they make sure that they minimize cost. And the problem we're dealing with here is the minimization problem. So our objective will be minimizing total cost. But what is the expression for total cost? The total cost is just given by price of labor multiplied by the amount of labor plus price of capital multiplied by the amount of capital, and plus here the constraint will be the production function that we have in here. So we'll just take these things to the other side so that we have lambda there, then Q will be minus 2K 1 over 4 L 1 over 4, just like so. So from here we can proceed now to get the partial derivatives of labor as well as capital. If you want, you can just go direct, then use the MRTS, which is just equal to the price ratio of labor and capital, which is just the wage and the rent. So if you want, you can go direct using this, but in this video, I prefer using the Lagrange because it shows us the objective as well as the constraint. In short, it gives us more information about the situation that we're dealing with. So let me just scroll a bit so that we have all over the board where we can work. So we have this expression here. So the next thing, we just need to get partial derivatives. Let's begin with L. When we differentiate that, we will just remain with W. And we go straight inside differentiate L. So we'll drop the power multiplied by 2 here. It will be just half. Then the power will reduce by 1, which will just give us negative 3 over 4. So this whole thing multiplied by lambda here will just be negative half here. Here 1 over 4. Then L is raised to the new power, which is negative 3 over 4. Then lambda here. So the next thing is just to make this term 0. And when we make it 0, we'll bring this thing to the other side. It will be just half. We'll have K 1 over 4 L negative 3 over 4. Lambda is equal to W here. So we just name this as our equation 1. Let's go to equation 2, which will be partial derivative with respect to capital. So just like we did to labor, we come here in the term with capital, we differentiate that, we remain with R, then we go inside, differentiate capital, this power will drop, then it will be a half again, then this will reduce by 1, then it will be just the one we had with labor. Multiplied by lambda here, it will be just negative half K to the new power, which is negative 3 over 4, then L will be 1 over 4. Then if we zero that, we take that to the other side like we did, we're going to have a half, then the K, negative 3 over 4, L 1 over 4, then this will be equal to R. So what we need to do here is to get the third. This one we can name it as our second. To get the third will be with respect to lambda. This one, notice that when we differentiate lambda here, we will just remain with the things inside here. So we just need to copy those things and paste here. So we'll have it to the power 1 over 4, and here 1 over 4 like that. And this is our equation 3. It's not really important in this because we're not going to use it, but well, it's important that we show it in our workings. So let's go on and just equate what we have found here, equation 1 and equation 2. So this term here is just the same as the marginal product of labor. Then this as well is just the same as the marginal product of capital. So we can divide that, and it will be equal to the price ratio, which is the length, and I mean the wage and the length. So notice that if you went with the MRTS, if you just went direct using this, then it's just all the same. So we can get that, which is 1 over 2k, 1 over 4, L, negative 3 over 4. Lambda here is equals to W divided by this term here, the other one, which is half k, negative 3 over 4. Then we'll have L, 1 over 4 lambda there. This will be like that. So from here we can cancel some things. Notice that this half and that half has nothing to do in here, as well as the lambda and the lambda has nothing to do as well. So what will remain with is just the k and the k, which are dividing. Now, if things are dividing according to the laws of exponents, we are going to get the common base and subtract the powers. So if we do so, we will have k 1 over 4 minus open bracket 3 over 4, negative 3 over 4. Then we can also notice that labor is also dividing. So we get the common base, then we subtract the powers. 3 minus 1 over 4 like that. So let me just clear the board. So before we write here, let me just try to simplify this table. So when we multiply this negative by that negative, we will have a positive here, then this will be gone. It will be positive. So we can remove that, and we can notice that we have the 4, which is common, which is just a common denominator there, then 1 plus 3 is just a 4. So this will be just equal to k. So we will have a k here. Then coming to this term here, we will have L. Then we can have the common denominator, which is 4. Then this negative minus that, it will be negative 4. Then this L will be just raised to negative 1, which is just equal to 1 over L. So this will be multiplied by 1 over L is equal to W over R like that. So this is just the same as writing like so. This is K like that. So here we can just cross and multiply. So we will have the price of capital multiplied by capital is equal to price of labor multiplied by the amount of labor. So here we need to make capital the subject and labor the subject. So let's begin with capital. To make it the subject, we just need to divide by R everywhere, and capital will be just W over R like that. Then this one, labor, let me just lap that and show you how it is done. Here we add the R. Then if we want to make this one the subject, we will just divide by W everywhere, just like that. Then L, this will cancel. Then we will remain with RK over W like that. So the next thing from here that we need to do, let me just clear this as not important at this moment so that we can create some space. So what we need to do is to find now the optimal bundle, the optimal amount of capital and labor. By doing what? By plugging in the values that we have found here into the constraint. And if you recall, our constraint is just a production function which is of this form. So here, if you want capital, you replace labor. If you want labor, you replace capital. So I want to start with capital. So I'll replace labor. I'll say production is equal to capital, I'll maintain it because I want to find the value of it. Then I'll replace bar, which will be of this term, R here like that, and W. Then we'll have 1 over 4 outside. Then we can just solve this on the other side here. So Q will be equal to 2k, 1 over 4. We distribute the power here. So we'll have rent 1 over 4, then capital 1 over 4, as well as W 1 over 4, like that. So here we can cross and multiply because we want to make capital the subject. So we will have Q W 1 over 4 is equal to 2. Then we can see that the K and the K are common. So we can just get 1. But before we do that, let's write the R 1 over 4 here. Then the K will be here. So the 1 over 4 plus 1 over 4, we will just have the power of 1 over 2 like that. Then we don't need this as well. We need to divide both sides by that, which will be like that, and that, which will be like that. So here we remain with k raised to 1 over 2 is equal to, because this will cancel, q w 1 over 4 over 2 r 1 over 4, like that. So the next thing here is to make sure that we remain with k raised to power 1. But how do we do that? We just have to multiply everywhere with the square. So that when that 2 multiplies with a half, we remain with k raised to power 1. Then these things, the whole root of these things are squared. So we will have q squared and w squared, it will be half over 2 squared will be 4. Then r will be 1 over 2. Then the final answer for k will be of this form, just to make it a little bit smart. Well, let me write it here. It will be q squared. Let me write just 1 over 4 here. Then, because this power and that power are common, we can factorize them. So we will have w over r like so. So this is the optimal k that we have in this form. Or you can leave it in this form, but it looks a little bit smart in this form. So let's now solve L. So to solve L, we'll go through the same process. We'll say 2k 1 over 4 L 1 over 4 like that. Then we're going to replace this because we want this. So Q will be equal to 2. What was the K? The K is here. We have L like that. Then R 1 over 4. Multiply by raised to 1 over 4. And here we have Q. So we can distribute the power there. We will have W 1 over 4, L 1 over 4 over R 1 over 4 multiplied by L 1 over 4 like that. So this we can cross and multiply so that we have Q R 1 over 4 is equal to 2 W. Then this L and that L are common, so we can add the powers and we will have L raised to power half. Then we can divide this both sides because we don't need it. We want to make L the subject of the formula. So we will have that 1 over 4 like that. We just clear this because we might get confused. So we'll have this cancelled. In our L, we will just be 1 over 2 like that. Then Q, W, oh sorry, it must be a R there. So we'll have R 1 over 4, everything divided by 2, W 1 over 4 like that. So here, like we did, we can make L just raised to power 1 simply by making sure that we square everything so that the square can cancel with the half. So let me clear this. So here will be Q squared R 1 over 2 divided by 4 W 1 over 2. Let's go to Q squared 1 over 4 R over W, factorizing the powers, 1 over 2 like that. And this is our optimal L. So that's it for question 1. Let's go on and solve question 2. The second question is this one. Derive the total cost function, average cost function, marginal cost function. So let's begin with the one we have been commanded to start with, the TC. So the TC will be our W, amount of labor, then R, then the capital. We have found this as well as that. So all we need is just to plug in that information. For labor, we had Q squared multiplied by R half, then 4W raised to power half, like that. So this will be plus R, we plug in capital. So capital we had Q squared, W half over 4, then we have R 1 over 2 like that. And we close the brackets like that. So let me just scroll down to the blue board as usual. So from here, we just need, first of all, if you've noticed, this W and the W are dividing. So we can divide that. Here we have a 1. So we get a common. Then we divide the powers. We subtract the powers. 1 minus half, we just remain with half. Then we will have multiplied by Q and R half, like that. Then this is divided by 4. We have plus, this R and that R is dividing. But just like what we got here, we will have as well R to the power half. Then the Q squared W half, like that, divided by 4. And we can notice something here. The 4 and the Q squared are common, so we can factor out that. We have 1 over 4 Q squared. Then we're going to remain with here, we'll have W half, R half, like that. Then in here, multiplying that and that, we're going to remain with half W half, like that. So one thing that we can notice again is that this term, that term are common, so we can add them. In case maybe you're wondering, are they common or what? We just grab this and try to put it in the arrangement of the other, which is starting with W. We have half there, and we'll have R power half, like that. So we can see that we can add these terms because they are common. So we will have 1 over 4 Q squared, and we'll have 2 W half and R half, like that. So these 2 and that can cancel. We remain with 2 there. So the final answer, the TC, is just equal to half Q squared W, or let me just multiply this because we have nothing to do with ever. So we can have W half R half, like this. So this is our TC. Now, let's go on and get the average cost. So average cost, AC, is just equal to total cost divided by quantity. So what we're going to do here is we're going to plug in the total cost that we've just found, which is half Q squared W half R half. Then divide this by Q. Then this Q and that Q will divide. It will remain with 1, it will remain with Q. So we will have half Q W half R half, just like so. So this is our average cost. Let's go on and find the final one, which is the MC, the marginal cost. And this will be equal to the derivative of total cost with respect to quantity, which is Q. So getting what we found here as our total cost and differentiating that, we will have half here. Then I just want to go step by step. So we drop a 2 here. Q, the 2 will reduce by 1, then this will just follow like that. We have that. So this and that will go. So we'll remain with Q, W, F, R, F, just like so. So that's it for the second question. Let's go on and work on the third one, which is our last question. So sketching this graphs will be, let me just draw a sketch here. This is not too perfect, but it's just a sketch anyway. So we'll have that. So here will be 0, then here we'll have cost, then here we'll have Q like that. So let me just remind you of the costs that we had. So we had total cost equal to half Q squared W of 1 over 2 and R of 1 over 2 like that. Or let me just write well the power. This will be 1 over 2 like that. Then MC will be Q W 1 over 2 R1 over 2 and AC is just 1 over 2 QW 1 over 2 R 1 over 2 like that. So this is what we got. So if you notice on our graph that we only have quantity and cost. So what we need to do is we'll just fix this. Because here we are trying to study the relationship between quantity and cost. When we change cost, I mean quantity, what will be the cost? So fixing this, I mean, we need to say, okay, they are constant 1 and 1. So they'll be just like that. And we'll remain with just this part, that part, and that part. We'll remain with quantity just everywhere. And the second thing that we need to do is to just assume the domain for Q. In this case, I'll say 0, like what I've written here, then 1, 2, just 3. I don't want to complicate my life, but you can choose your own figures. We're just assuming. So I'll say if this is 0, say this is 1, this is 2, and this is 3, like so. Then on the other side, I'll say, okay, I have a 4 there, I have a 6, okay, I have a 9 there, just like that. So notice, if I put a 0 in GC, I'll get a 0. So I'm starting from 0 there. So if I put a 1 in here, 1 squared is just a 1 multiplied by half is half. So it will be 1 comma half somewhere. So it will be somewhere here. Then if I put a 2, 2 squared will be 4. Then divided by 2, it will be just a 2. And it will be somewhere here. We're just sketching. I'll keep on reminding you of that. Then if we put a 3 here, we put in here, it will be 9. 9 divided by 2, it will be 4.5. And 4.5 is somewhere right here. So all we need is just to join these points like so. We're just sketching and it's not too perfect, but this is the TC. So the second thing is the MC. So let's work with the MC, or rather let's start with the AC. So AC will be, if we put a 0, we will have a 0. So we're starting from 0 as well. If we put a 1, we'll have a half, so we are here. Then if we put a 2, we will have a 1. So a 1 will be somewhere uh, here. We're just assuming, sketching. So if we put a 3, we will have 1 point something, and 1 point something will be somewhere here. So this curve will go somewhere just to pass exactly. Well, I've just created everything. So it will go like that, like that. This curve will pass like that. So this is SN. Let's go on the last one, which is MC. So MC, notice that is just equal to Q. So it will take Q values. And if you plot this, it will just be somewhere, or maybe let's just plot it. So it will be 1, 1, 0, 0 first of all. then 1 comma 1 somewhere, then 2 comma 2 there, then it will be 3 comma 3 somewhere. So it will be above the average cost. So it will be like that. The other thing you can notice is that maybe when you are approaching this, you could find that you have straight lines. Well, it's just fine because if you notice, we made this to be constant. And if you can see this, it's in the form of the linear function. So it can be a straight line in this case. But well, there are curves, like the question stated, because if we consider other variables, we're just getting, a to be curve. So in this case, yeah, it can be a straight line, but we know these are curves. So this is our MC, while the other one is the average cost.